Rightio, hello Year 9. Today we're going to be solving linear equations, but this time we're going to have the equation, or the equation with x variables on both sides, or the unknown on both sides. So your step is that you're going to be able to solve linear equations with the unknown on both sides. That's wrong because that's 3.1. Okay, so the first step in solving equations with a pronumeral term on each side is to remove the pronumeral term from one side. Now that can be performed, or it can be removed, by performing the inverse operation, generally adding or subtracting on both sides of the equation, that an equivalent equation is formed. Now in some cases it may be easier just to swap the sides of an equation so that the pronumeral term with the larger coefficient is on one side. Now a literal equation or formula contains two or more different pronumerals. The balance method can also be used to rearrange a literal equation or formula. Rearranging a formula then is also known as transforming a formula. So let's have a look at our first example. Our first direct example is solving an equation with an unknown on both sides. So we've got 8x take 9 equals 5x plus 6. So, okay, so we've got, let's grab a pen, we've got 8x take 9 equals 5x plus 6. What I want to do is just put pronumerals on one side and constants on the other side. So let's move that 5x and we'll put it on the left hand side. So what we do is we go, well, 8x take 9 take 5x equals 5x take 5x plus 6. So let's have a look at the idea here. We could see that in the front of this top 5x it's a positive. So to do the opposite of the positive 5x is I have to do a negative 5x on both sides. So what I've done is written an equivalent equation. Now do not put an equal sign there. If you want to put anything you can put 3 dots, and that means therefore, and that's a logical deduction. So now let's have a look what we've said. We've said 8x take 5x. Well, 8x take 5x is 3x. Now 3x take 9, well, we're going to find that and we'll probably get rid of that side, and that plus 9 at the moment equals 6. I don't even need to put that positive in front of the 6, so that's going to be there. So what do I need to think about now? It's this minus 9. So the opposite of that, or the inverse, is plus 9. So that's plus 9. So let's do this. 3x equals 6 plus 9. Well, that's got to be 15. Now I try and get rid of the 3. So I do that by doing the opposite of times 3, which is divided by 3. So x equals 5. Now I can just substitute that into the equation to see if the left hand side equals the right hand side. So my check is 8 times 5 take 9 equals 5 times 5 plus 6. Does the left hand side equal the right hand side? Well, 5 eighths are 40. Now 40 take 9 is 31. Now what do we got here? 5 fives are 25 plus 6 equals 31. So yes, we find that the left hand side equals the right hand side. So we know that we are correct. Let's look at the next problem. 3x plus 7 equals negative 3 take 2x. So there's a couple of different ways I can attack this one, but which is nice. What are we going to do? We're going to try and get rid of the 2x on this side first, I think. So the opposite of the minus 2x is a plus 2x. So we're going to rewrite our equation like this. 3x plus 2x plus 7 equals negative 3 minus 2x plus 2x. So you can see that what I've done on one side of the equation, I've done to the other side. So let's rewrite it. So 3x plus 7, now I'm going to leave a little bit of space because I'm going to get rid of that 7 soon, equals negative 3. Okay, so what do I want to do now? I want to get rid of that negative 7 on the left hand side. So what do? I do the opposite of the positive 7, which is going to be a negative 7. So now we can say, well, 3x equals, or negative 3 take 7, well, that's got to be negative 10. And I think I've done something wrong there. Let's have a look. So this is always good to check my work. Okay, can you see where I've gone wrong here? That should be a 5x. So I might just fix that up. So that should be a 5x. That should be a 5x. It's a good thing I've got an eraser on this pen. Sorry about that, students. And then let's continue with where I should be. So, well, 5x equals negative 10. Well, the opposite of multiplied by 5 is divided by 5, and so therefore x equals negative 2. We can just substitute that into our equation as a check. So what is it? 3 times 3x plus 7, so 3 times negative 2 plus 7 equals negative 3. Take 2 times negative 2. So, well, 3 times negative 2 is negative 6. Negative 6 plus 7 is positive 1. Now, I need to do this one first because that's my order of operation. 2 times negative 2 is negative 4. And negative 3, take negative 4. Let's just rewrite this. Take negative 4. Well, yeah, that's got to equal 1. So, yes, I'm comfortable that I'm on the right, that I've got the right solution. Now, what if we've got some brackets? Well, I'm just going to have to expand using the distributive law. So let's have a look at this one. I've got 3 and then 2x plus 1 equals negative 4x take 17. So let's just expand this bit using the distributive law. So it's 3 times 2x equals 6x plus 1. So, well, plus 3 times 1, isn't it? There we go. 6x plus 3 now equals 4x take 17. So let's get rid of this negative 4. So we're just going to go 6x take 4x plus 3 equals 4x take 4x take 17. Now those two 4x's cancel each other out, so that's nice. So we rewrite our equation. Now don't be afraid to just space your work out a little bit if it's getting messy. Well, 6x take 4x is 2x. I better just check my work because that's where I made my mistake last time. Plus 3. Well, this time I'm going to be thinking ahead. I'm going to get rid of that plus 3. So I might as well put that in now. I said, well, negative 17. And I want to get rid of that extra 3. Well, 2x equals negative 20. Oh, okay, so now I can just divide both sides by 2. And let's say x should equal negative 10. Let's just substitute into the equation, and let's just to make sure that we're on the right track. So 3 times 2 times negative 10 plus 1 equals 4x take 17. So let's now do, well, 2 times negative 10 is negative 20. Negative 20 plus 1 is 19. Well, 3 19s, well, 3 20s are what? 60, so 60 take 3 has got to be 57. Let's just put that in there while I'm thinking. Now, 4x is, 4 times negative 10 takes 17. Okay, well, 4 times negative 10 is negative 40. Negative 40 takes 17. Yeah, that's 57. So my left-hand side equals my right-hand side. Okay, if we've got algebraic fractions with denominators on the both sides, well, essentially we can just cancel the denominators. So we're just going to say, well, 4x take 3 over 5 equals 2x plus 9 over 5. Well, I can multiply both sides by 5 and I will just cancel each of those out. So what I'm really going to say then is 4x take 3 equals 2x plus 9. So then I can just go, well, 4x take 2x equals 9 plus 3. Can you see what I did here? I did 2 steps in one. So I did the 2x there and I've just stopped rewriting the plus 2x minus 2x and then I've done the inverse operation over here. So I've jumped ahead and solved this fairly quickly, and this is when you get fluent, this is what you'll be doing. So then we'll go, well, 4x equals 12 over 4 over 4, x equals 3. So this is the very minimum sort of working that we're seeing with these 3 lines here. 4 lines, sorry. This is just taking a while, so I'm trying to go through it a little bit quicker. Okay, if you might get faced with a problem-solving question like this. So Bill, Jill and Phil, their ages all add up to 100. So we know that Bill is half as old as Jill and 4 years younger than Bill. How old is Bill? So what we'll do is say, well, we don't know how old Bill's age is, but we've been told that Jill is twice as old as Bill. So 2 Bills is the same as saying 1 Jill. And then we've said that he's 4 years younger than Phil. So Bill plus 4 must equal Phil. So what we've now can say is, well, we've got a total of 100 years. And 100 years equals Bill plus 2 Bills, which is Jill, plus Phil, which is just a Bill plus 4. So what we can do now is just collect the like terms and simplify. So remember, these are our like terms. So 100 equals 4 Bills plus 4. Then we can just say, well, 96 equals 4 Bills, and then 96 over 4. 4 times 24 equals 96, so therefore Bill is 24 years old. Another tricky one that you might come across is something like this. The sum of 5 consecutive numbers is 60. Determine the value of the numbers. So what you need to do is just think, well, the first number is what we're going to start off with. Now, consecutive means they're in order after each other. So the second number is going to be n plus 1. The third number will be n plus 2, and so on. And so that's what you can see here. So let's rewrite our expression. We've said that 60 is the same of 5 consecutive numbers. So the first number is n, our second number is n plus 1, our third number is n plus 2, our fourth number is n plus 3, and our fifth number is n plus 4. So let's collect our like terms, and I can see 1, 2, 3, 4, 5 n's. So 5n, and then let's collect the other terms. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So 5n plus 10. Now we can just go, well, let's get rid of that 10. So 60 take 10 equals 5n. So 50 equals 5n. And you can see where I'm going with this, just dividing both sides by 5. I'll put the pronumeral on the left, and then n equals 10. Now we can just substitute and check your work there. Okay, when you've done that, I'd like you to work on your mastery exercises, please, Year 9.